Good morning, everyone. I am here with Zach Goodman today, and he's going to talk to everybody about indoor air quality. We had Zach here in early February to talk about sewer inspection and repair, so if he sounds familiar, that is why. We will also have Zach coming up in May, on May 17th at 9:30. He's going to do a full hour on the new asbestos regulations for 2019. So if you have any questions, this webinar will answer those, and I will send a link out to register for that after this webinar is over. I'll also send a link out where you can ask any questions that you have regarding the new asbestos changes ahead of time, so Zach can be prepared to answer those for you. So we're so excited to have Zach here. Zach has been with Alpha Environmental Service, Salem branch manager, and has 13 years of experience in the environmental field. His experience includes underground tank locating, testing, decommissioning, and cleanup to Oregon and Washington requirements, radon testing and mitigation, mold assessment, testing and remediation, sewer scoping and repair, lead and asbestos surveys, and phase 1 and phase 2 environmental site assessments. In November 2017, Zach started Alpha's Salem branch and is its manager, providing all of the above services to the Salem area and surrounding community. Zach has a Bachelor of Science from Marylhurst University in Environmental Science and licensed heat oil tank supervisor. He also has DEQ's UST supervisor license and is a licensed Washington site assessor. He spent 2 years at Idaho Department of Environmental Quality before working at Alpha, reviewing environmental projects. So I'm so excited to have Zach here today. Without further ado, go ahead and take it over.
Thank you very much, Kayla. Yeah, as was noted this morning, we are doing a presentation on indoor air quality. And you might note from my background that indoor air quality is not among the items listed in there. Indoor air quality is a complex field in how it can be assessed and how it can be viewed. There are a minimal amount of regulations for indoor air quality, and that's in part how the presentation's laid out, is to provide a little bit more of a science background to explain why the field has been approached as it is and how specifically Alpha Environmental chooses to approach this field. We don't want to be a fear-based company, and as a whole, indoor air quality doesn't need to be a fear-based industry. It should be viewed scientifically, and then that way it can be viewed logically with a view to solutions rather than the concerns and conditions that can be a result from indoor air quality. We've already gone over my credentials, so we will go right into the outline for this presentation. You can see that there's a few bullet points here. The first is our environment, and again, we want to discuss our environment because that is a large part of how we look at this field. Is we live in a world with a lot of different conditions, climate change, and a lot of different things that can affect us. So we want to look briefly at our environment before we get into the overall topic of indoor air quality. The second topic we'll be looking at briefly is atmospheric contaminants. These are both natural and man-made, and it helps to look at both of those in affecting how the residents of a house or in a commercial building can be affected. Then specifically, we'll be looking at indoor air contaminants, what's specifically in a building, and then a IAQ assessment, that's indoor air quality assessment. We'll be looking at health effects for specific contaminants, and then we'll be looking at prevention and mitigation of the contaminants that are identified in buildings. We'll also be looking briefly at sick building syndrome, which is something that's been publicized about not only in the news, but other media sources. And there's perhaps some misinformation about this, but it is certainly something that comes up enough that it's something we would need to touch on in a presentation like this. So the Earth's atmosphere. The Earth's atmosphere has outdoor air transferring to indoor air. This is obvious, but it is worth noting. So the outdoor air, our natural environment and atmosphere are a result of plant photosynthesis and decay. Essentially, inhaling carbon dioxide and water and exhaling molecular oxygen. So this is worth noting because there's a constant chemical process that's taking place. Even for those that live in very urban areas, there is still plant activity, and this is taking part on a global scale. So even if there are not major forests around or other bodies of vegetation, this is a process that continually takes place and is worth noting. So these natural processes result in a constantly living and changing atmosphere. You can see this pie chart notes a little bit of a chemical breakdown of our atmosphere. And it's worth noting that most of what is here is natural. It's largely nitrogen-based with oxygen, and there are levels of CO2, hydrogen, krypton, methane, helium, neon, xenon, and even radon, which will not be discussed at length in this presentation, but it's worth noting that even something that is a known environmental concern like radon naturally occurs in our environment. So that can add a layer of complication when we look at assessing and treating the indoor air quality that we deal with. So outdoor air pollution and then the natural sources of that. There's natural sources of air pollution such as dust from windblown soil and meteorites. And this is actually worth noting because dust is a huge source of particulates. And we'll get into particulates, what those are and how those affect people. But that is one of the most common issues with indoor air quality is simply particulates in the air that cause simple respiratory issues. Other natural sources include sea spray, similar concept in a way that there's minerals found in seawater, and those minerals can actually get into the air and cause minor indoor air quality issues. Smoke from forest and grassland fires, for those that are in Oregon and California, you likely have been aware of those in the last couple of years, and might be more aware of how those can certainly cause respiratory issues. Volcanic eruption and activity, biogenic emissions from plants and animals. All those things are natural sources, and actually a few of those specifically will affect indoor air quality. Outdoor air pollution, some of the natural sources. There's some very good charts or pictures on the right side of the presentation, and I want to note those here. You can see that everything is a bit of a process. So we live in a state, Oregon, with constant weather change, and we know from living here that there is a lot of weather patterns that cause kind of a mixture of these natural pollutants into our atmosphere. These pollutants are mixed and can travel thousands of miles from their source. So they're removed primarily by clouds and precipitation. So when we have forest fires and effects like that, even when they are far away, we see the effects here in urban areas like Salem and Portland, and certainly the surrounding communities as well. So now outdoor air pollution, man-made sources. This is probably the one that's considered the biggest issue, maybe in part because it's the one we can most affect. Man-made sources of outdoor air pollution primarily compromise emissions from vehicles and industrial plants. This is obvious, but typical man-made emissions may include carbon monoxide, soot, which is a solid carbon, and that's specifically a carbon footprint that's been talked about much in recent years about trying to reduce, nitrogen dioxide, benzene, arsenic, formaldehyde, sulfur dioxide, ozone, and ash, solid ash. We won't be looking at every one of these pollutants specifically because they fall in part under other areas that we'll be looking at. For example, if we look at particulates, we'll actually find that solid carbon and ash both would fall under that area of assessment and treatment. Again, I think it's helpful to have a little bit of a picture of how everything takes place. So you see here, there's a number of different areas. On the left side, you see forests, wildfires, volcanoes, some of the natural areas of impact. And then we see cities. We know a lot about the discharges that can occur from cities, but even areas that are rural, livestock and fertilizer, those have different types of emissions. And stationary, like manufacturing facilities. And then of course, cars, trucks, buses, motorcycles, vehicles, they all have known discharges. So all of this is mixing into our environment, and that ultimately can be something that gets put into our indoor air quality. And so that is why we look at such a wide area of pollutants. So now we get into indoor air itself. Where is this indoor air coming from? Outdoor air gets into indoors due to ventilation, infiltration, exfiltration, simple opening doors and windows, gaps around doors and windows, and cracks in the foundation. Even convection of indoor air that we generate heat, hot air rises and is replaced by cooler air, which in turn heats, rises, and is replaced. So that's why we looked at some of those pictures earlier, is that's a simple process of thermodynamics. Cold air sits on the bottom, whether that's the earth as a whole or in a building, the lowest area, if that's a basement or a crawl space. And as it heats, it rises and then gets into the houses. So similarly to what we looked at before, where there's a cold and warm air circulation in the environment as a whole in the earth, we see this in houses as well. So it's a constant moving process of gases, both from subsurface, from the actual soils beneath houses. This is where things like radon get into houses, is air naturally will rise from the subsurface soils into the house and then will eventually be discharged. Gases like radon are more heavy, and so they can be more difficult to pull out, hence in a lot of cases why radon mitigation systems are installed, because those gases are often too heavy to escape on their own, or at least have an accumulation factor. So indoor air, we spend about 90% of our time indoors. So obviously indoor air and indoor air quality are a big concern. Since the 1970s, buildings have been built more tightly to save on heating and cooling costs. So this makes it even perhaps a bigger issue. So daily, a family of 5 will inhale and exhale about 150 pounds of air. And then in this time, they'll be generating carbon dioxide and water vapor. And this can add to indoor air quality issues, specifically carbon dioxide. We'll get to carbon dioxide in a little bit later, but carbon dioxide is something that actually can have some minor health effects, especially when it accumulates in a building. So more people that are in a living area or a dwelling area, whether that's a home or a commercial property, that can cause carbon dioxide levels to build up and actually affect the indoor air quality negatively over time. Indoor air can also be affected by manufactured materials such as carpets, drywall, paints, cleaners, cosmetics, and furnitures from simple off-gas chemicals. Some of these might have been more publicized. There have been drywall materials that have been imported that have caused some of these off-gassing issues. I think most people understand that paints have off-gassing. A lot of cosmetics and furnitures also can have off-gassing, especially depending on the quality of what it is. Other common contaminants can include simple skin shell shedding, pets, fur, fiber from materials such as clothing, carpeting, towels that break off, and mold spores can actually be tracked from outside to inside by simply being in areas with high mold areas or high pollen areas. So those that live in rural areas are more likely to track some of that inside from wherever they were outside that had those issues. At the bottom here, there's 5 different pictures. These are kind of the 5 most common things that we look at as potential sources of indoor air quality issues. Moisture can cause mold over time, especially in areas that are not well ventilated. VOCs and chemicals, this is what's been mentioned briefly in this slide from different manufactured materials. Smoking, especially when smoking is done indoors, that can actually add a lot of indoor air quality issues over time to people that don't even smoke. And dust, as mentioned, dust can result in particulate buildup, and that particulate buildup can also add in issues with mold, because those particulates will actually have mold spores adhered to them, so then that in turn can cause issues with indoor air quality. And pet dander, that can also cause the same similar issues. Is there's simply things in the air that are not normal to breathe, so that can affect people in different ways. So having looked briefly at the atmosphere and how that can then affect the indoor air that we breathe, how can we assess indoor air? This is perhaps the most complex question that we deal with indoor air quality, because there's literally thousands of different things we could test for. And unfortunately, we cannot rely simply on odors. This is probably the most common call that we get in regards to the initial inquiry of whether indoor air quality or perhaps mold testing is needed is a simple smell in the house. And unfortunately, we can't rely on that. In our experience, when we go out to properties that have so-called odor issues, we often find that the mold counts are relatively low. In most cases, the mold counts are very similar from the inside to outside, which is in large part why we often test for mold, both inside and outside, to have a background level of comparison for the indoor assessment. Secondly, we cannot smell some things at all, such as carbon monoxide. Some people might say that they can smell things like dust. That's not uncommon. Smoking, VOCs and chemicals, and pet dander are all things people can smell in some situations. But again, it's very difficult to rely on something that cannot be tested simply by smelling in terms of this smells worse than this smell. So we don't have a good level of comparison to know whether there's truly an issue or if it's simply a higher level than what might be normal outside the house. And unfortunately, we cannot smell other things until after they've already affected our health. We can smell other things well before they affect our health. This can actually induce psychological symptoms where we have false positives for what we smell. So again, this is a little bit of a complex question, but thankfully there are ways that we can produce standards for assessing indoor air quality. In this case, we have chosen standards, and this has been chosen in part from what we've seen in the general industry. And we've also chosen certain contaminants or parameters to measure. Instead of testing every single one of thousands of different chemicals and having a test that would cost thousands of dollars just to find out whether there were issues, we've chosen a few general parameters to begin exploring whether there are indoor air quality issues in a house. And we'll get to that a little bit later about how the testing is done and the costs for that. But we have a relatively simple test that only costs a couple $100 versus a couple thousand to actually get an idea of whether there's indoor air quality issues. So once we've established standards and parameters, then we can then measure their values in air. And a number of these parameters that we've chosen have been chosen because there are industry standards by the Environmental Protection Agency and OSHA that have been documented and proven to be concerns for human health. So then we can compare the measured values to those standards. Overall, it really depends on what we want to accomplish with assessing indoor air quality and then, of course, getting to the point of treatment, which is really the goal with any sort of environmental testing. Is there needs to be some sort of way that we can determine mitigation on these. So that's how we make it our goal to protect against illness and maximize health and well-being. And it does vary from house to house and from person to person. We've dealt with situations where people have lived in areas with high mold or high other areas of indoor air quality contaminants, and they have not been affected at all. And in some cases, we've tested houses with two people living in the same house, one that was severely affected and one that wasn't affected at all. So ultimately, again, it needs to be site-specific and person-conditioned. And we do have these parameters that help us to know in general if something is a concern, but every situation is different. Just because levels might be considered low or quote unquote safe doesn't mean that the person that is affecting or feeling what they are feeling, it doesn't mean that they are liars or that they're simply, they have a psychological symptoms. In some cases, they just have very compromised immune systems, which is why they're feeling the effects that they do with indoor air quality issues that they have. So getting to indoor air quality standards, by definition, indoor air quality is measure of atmosphere in a space of occupancy. Measurements are assessed against standards EPA has provided, or in some cases OSHA. Poor indoor air quality can result in anything from asthma to headaches, poor sleep, dizziness, weakness, nausea, drowsiness, damage to organs, or more severe symptoms. As noted, this really varies from person to person. It's not uncommon to have situations where someone has a light headache from some levels, and another person might have very severe conditions that are similar to asthma, hard time breathing, severe headaches, breaking out on skin and rashes. So as a result, the testing standards are based on known contributions to those symptoms. So which constituents to assess? And this is something that is primarily chosen by Alpha, what constituents to assess. If you ever have a situation where another component might need to be assessed, we often can provide a measure for that testing. But in a lot of cases, as noted, the things that have been chosen because they are broad parameters for testing. So if there are issues, they are generally going to be found as part of one of these tests. So what we typically test for is carbon dioxide, carbon monoxide, total VOCs. We also test for temperature, relative humidity, and particulates. So there might be a question of temperature and relative humidity. Why would we test for those? Well, heightened temperature can result in higher concentrations of other indoor air quality issues. Relative humidity also can have effects on different people depending on their immune systems. So we'll get into the individual things that we've chosen to assess and what the standards are, and then additionally what health effects can occur from those. So we'll start in order with carbon dioxide. The normal outdoor level of carbon dioxide is about 400 parts per million. And parts per million is simply a standard used in the environmental industry. It's essentially 1 part per million is 1 particulate in a million total particulates. So in this case, it's 400 total particulates in that same range. We exhale carbon dioxide in concentrations 100 times greater than outdoor levels. So going back to that, what we discussed briefly earlier, when we have multiple people in a same living area or occupancy area, we have a situation where that buildup can occur. This makes carbon dioxide useful as a tracer gas to estimate actual indoor ventilation rates. Shortness of breath and increased heartbeat frequency begin when concentrations reach 15,000 parts per million, which is almost 40 times greater than outdoor levels. So again, as an accumulation factor occurs with carbon dioxide, there can be a number of health effects. And we'll see those briefly on the next slide. Indoor concentrations above 750 parts per million can affect worker productivity. So again, going back to the previous slide briefly, the normal outdoor level of carbon dioxide is about 400 parts per million. So this is less than twice what typical outdoor levels of carbon dioxide are. So it doesn't take very much for a buildup to occur. And this has been linked from different studies that even at indoor concentrations above 750 parts per million, that can actually affect worker productivity. Some of that is more measurable than others. It can be viewed as irritation or simply difficulties breathing. So Alpha recommends that indoor carbon dioxide levels not exceed 750 parts per million. So typically ventilation of residence or occupancy areas to keep the CO2 levels, that's carbon dioxide, at or below 750 parts per million means that we're also reducing concentrations of other potentially troublesome gases. So again, using this as a tracer gas, if there is a buildup of carbon dioxide, then it also stands to reason that there would be a buildup of other gases that are being contributed by humans or other potential man-made pollutants, cleaners, and that sort of thing. So improving the conditions might be as simple as adding ventilation to the area. Now, carbon monoxide. Carbon monoxide binds to hemoglobin in the blood with an affinity of 200 times that of oxygen. This seriously impairs the blood's ability to carry oxygen. You might remember from a science class back in the day where a teacher talks about carbon monoxide. And essentially what blood is doing is it's carrying oxygen cells to different areas of the body. So what carbon monoxide does is it prevents the oxygen from being absorbed by the blood. And so the oxygen won't be able to reach different areas of the body. So this can be observed in shortness of breath, even in areas where there is good oxygen because the person has been exposed to high areas of carbon monoxide. So there's a number of possible indoor sources such as gas-powered furnaces and water heaters, cars running in attached garages. This is why that is dangerous to have a car running in a garage. Those carbon monoxide levels build up in a garage to a point where it is literally toxic and it will literally kill you. And burning of fuels indoors, such as gas or charcoal grill, that can also cause carbon monoxide, as well as clogged fireplaces and chimneys. So we don't often see this as much of an issue in commercial buildings, but in some cases we do. This is primarily an issue when it's seen in residential properties. So carbon monoxide has noticeable health effects that began at about 35 parts per million. Home CO, carbon monoxide alarms, that's CO, alarms go off at 70 parts per million after an extended time. Home alarms are designed to save lives, but not necessarily to prevent health impacts. Serious health impacts appear at 400 to 800 parts per million. The World Health Organization recommends no more than 6 parts per million of carbon monoxide over a 24-hour period. So as a result, the 6 parts per million is alpha standard, because there can be health effects even from a small amount as that, the 6 parts per million. So unfortunately, having a home with a CO monitor, which most homes thankfully have these days, it doesn't necessarily mean that the house is considered safe from carbon monoxide, because those carbon monoxides go off at 70 parts per million instead of 6 parts per million, which is a better industry standard in terms of health effects. So VOCs. VOC stands for volatile organic compounds. And we'll look at a number of different volatile organic compounds that could be in the air as part of this. Volatile organic compounds could include benzene, it could include naphthalene, ethylbenzene, which are common from underground storage tank leaking. They are also common from different types of cleaners, and a variety of products have actually been manufactured with other types of VOCs. So unfortunately, VOCs are more common than we'd like to think. So what a VOC technically is it's a volatile component, which means a chemical that is a gas or vapor. It's an organic compound, meaning that it contains carbon. So that might in and of itself sound nice, but a volatile organic compound tends to be chemically reactive, unstable, and different types of VOCs have been linked to things like cancer. So VOCs are emitted from many household items, such as drywall, ceiling tiles, laminated floors, wall coverings, furniture, curtains, office equipment, paints, coatings, adhesives, cleaning products, disinfectants, cosmetics, aerosol sprays, air fresheners, dry clean clothes, mothballs, that's specifically where naphthalene will come from, fossil fuels, and burning tobacco. And it should be noted, this again doesn't need to be a fear-based thing. These are simply potential sources of VOCs. It doesn't mean that every single drywall or every single piece of furniture has VOCs, and it certainly doesn't mean that every single drywall or furniture or anything in this list will have VOCs that are immediately a concern, that we should simply live in empty houses. It simply means that this is a source of potential VOCs, which in turn can cause VOC buildup within a house. So again, some of the notable VOCs that we've touched on briefly, there are thousands of VOCs, literally thousands. And some of the more notable ones are benzene, which specifically can come from tobacco smoke, gasoline, and vehicle exhaust. And levels are about 10 times higher in smokers and non-smokers. Naphthalene, one of the sources is mothballs. And naphthalene also can come from different types of petroleum fuels. TCE and PCE, that's mainly associated with dry cleaners. Those are considered pretty hazardous VOCs. They aren't used primarily in anything other than dry cleaners. Acetone and ethyl acetate are different types of solvents. Acetone you might be familiar with if you have cosmetics. CFCs were previously used as refrigerants. Methylene chloride, which metallizes to form carbon monoxide, so therefore it's kind of a double concern because in and of itself it's a VOC and can contribute to carbon monoxide. And MTBE was also commonly used in gasoline. So some of these are not as common as they used to be, but in older properties, there might be old gasoline sitting around the building or around the property that might have some of these more toxic levels of VOCs. The health effects of individual VOCs, such as TC and PC, cannot normally be assessed separately because their individual levels are typically too low to measure, and their effects cannot be differentiated from other VOCs. So this, again, kind of goes back to the problem of what to test for with indoor air quality. We could test for literally thousands of components, and a number of those are VOCs. And that would be helpful data in order to determine whether there is a true health risk, but it may not tell us how to solve the issue. And it also, of course, is more expensive to determine that than it could be to go straight to what ultimately would be the goal in terms of mitigation. Cumulative impact can be significant, and VOCs have similar health effects. And so they're considered collectively as total VOCs, and that's how we typically test them, as a total VOC. Most of the VOCs shouldn't be in the air we breathe anyway. Those are almost entirely from man-made contributions. So if we're seeing high levels of VOCs in a house or a occupancy area, it's likely because there's either poor ventilation or simply too many total chemicals in that area that are causing that buildup of VOCs. So VOC health effect. Short-term exposure to high levels of total VOCs can cause anything from eye, nose, throat, and respiratory irritation, headaches, dizziness, visual disorders, and memory impairment, allergic reactions, labored breathing, vomiting, declines in cholesterol levels, nosebleeds, fatigue, loss of coordination, and nausea. So when we hear situations about someone living in a house that has respiratory irritation, skin irritation, headaches can be really caused from almost any of these indoor air quality issues. But generally, when we see multiple symptoms in this list, we generally lean towards the issue being VOCs. And from our experience, that has proven to be correct. When people have these types of symptoms, it's been something that we can actually assess the house or assess the total property, in part with not only doing testing, but talking to the homeowner or people that might be living in that area in order to determine what the source might be. In a lot of cases, we can actually find not only whether there's a potential issue, but we can actually find the source. And that at least gives us a place of starting for addressing these concerns. So prolonged exposure to high levels of total VOCs can cause serious issues such as damage to the liver, kidney, central nervous system, and increased risk of leukemia, lymphoma, and cancer. Some individual VOCs are considered carcinogens, and that is actually in large part why some of the regulations are in place for underground storage tanks for fuel products, because those individual VOCs, if inhaled readily or affected directly onto the skin or ingested through contaminated groundwater, are a major concern because there's direct carcinogen correlations. So with total VOCs, which is what we look for in test, in studies of total VOCs above 3,000 micrograms per cubic meter consistently show health impacts. This is a slightly different form of measurement than parts per million, and this actually could be viewed as a parts per billion. And we use that in part because this is specifically an air issue. VOCs exist only in air. Levels above 500 parts per billion have not shown health impacts. So the LEED and alpha standard is 500 parts per billion for total VOCs. This is equivalent to about 3 to 6 drops of VOCs in a large swimming pool. So here we have a little bit of a study. There is 8,000 homes in this study, and 90 of them exceed the standard, the right of the line. This was taken in part from one of the companies that we work with in terms of testing, and this is based on their study. In about 8,000 homes, 90% of them exceed the standard. And again, it doesn't necessarily mean that the area should be considered toxic and unliving. You can kind of see how few are really in the severe area. That's less than 5% are really in the severe area. A number of them were in the moderate to elevated area. So this kind of goes back to one of the questions with indoor air quality is how do we look at assessing? And the standard, it is unique for every single house, for every single person. And so that's one of the things we want to consider is if someone is having obvious health effects, then it doesn't necessarily matter whether they're in the moderate, elevated, or severe, it is affecting them as if it is in severe. And therefore, they can be affected negatively just based on those levels, even if they're considered relatively low or even moderate. So now we'll look briefly at particulates. Particulates are solid or liquid particles suspended in air. And again, this could be a number of different things. So they range in size from a fraction of a micron to 100 microns. Larger particulates, 50 to 100 microns, can sometimes be seen, for example, streaming sunlight through windows. Particulates between 10 and 100 microns in dust readily are re-airborne indoors by breezes, household activities, vacuuming, etc. So simply opening the home can result in pollen coming through, mold spores, pet dander, human hair, and just regular dust can simply come in. And again, dust, because of what it is, it's actually considered a little bit larger. It can have pollen, mold adhering to it by coming into the house. So particulate sources. Very coarse particulates include human skin cells, pet dander, insect parts and droppings, fibers from paper products, and clothes and other textiles. Coarse particulates can include dust and salt from sea spray or other minerals from sea spray, pollen, plant and mold spores and bacteria, powdered ground crushed soils generated by industries. So you can see just about anything in the air can be considered a particulate. So it is a very general term and a very general thing that's being tested for. So this can be both good and bad. It's bad in that it might not link the exact source of the issue, but by testing for particulates, we cover a lot of different things. So fine particulates are generally byproducts of industrial activity, motor, vehicle combustion and operation, forest fires, chemical reactions in the air that produce solids, volcanic activity. They also may include soot or carbon, smoke, and viruses. Particulate health effects are a function of their size. Smaller particulates tend to have the greater impact on our health. And this is not a class necessarily on things like radon and asbestos, but this is a good point to note that. Asbestos in particular will often come up in a particulate source. And radon and asbestos in particular are smaller. And that is part of why they have such a great impact on our health, is they are absorbed in the deepest part of the lungs, and therefore they're not going to be removed. There isn't a natural body process that will remove those tiny particles from the deepest areas of the lungs. And that's different necessarily than, say, cigarette smoke that's breathed into the lungs, but may not be breathed as deeply as finer particles like asbestos. Radon is also an extremely small particle, and so it can have a similar effect in that way. So particulate health effects, because this is a wide range of potential issues, there is unfortunately a wide range of health effects. So the size ranges that we'll look at are greater than 10 microns, which are inhalable particles, between 2.5 and 10 microns, and between 0.1 and 2.5. Particles smaller than 0.1 microns don't have a particular name. So particulates larger than 10 microns are generally filtered out in the nose and throat in the upper respiratory system. These are called inhalable particles. So particulates between 2.5 and 10 microns can penetrate into the lungs. Those are called thoracic particles. This category includes most mold spores, typical in the Pacific Northwest. Particulates between 0.1 and 2.5 microns can penetrate into the bloodstream because of how small they are. So those are the ones that can cause disease, emphysema, and potentially cancer. So there's a little bit of a diagram on the right there, and you can at least have a little bit of an idea of what's happening here. So the larger particles are often sorted before they get too deep into the body. So even in the nasal cavity and down into the trachea and the general lung areas. These smaller particles, they're getting not only into the branches of the lungs, which you can see, at least hopefully in part on the right. Those are the small branches that are seen in the lungs themselves. So, and you can see that the branches, they get smaller and smaller. So the smallest areas are called the alveoli, and those are the areas where the smallest particles will accumulate, and therefore that's why it's so difficult for them to get out. So again, the smallest particles, the less than 0.1 microns, are the most hazardous. After getting into the blood, they can pass through cell membranes into organs. And unfortunately, there is believed to be no safe level of particulates. Exposure to particulate matter may contribute to tens of thousands of deaths per year in the United States. So, and this might be a good point of emphasizing that indoor air quality is it's an evolving science field. It's similar to asbestos, similar to radon, similar to mold, and it does often include those different areas. And it is an evolving field because the studies are still taking place. In large part, these studies have been around for less than 100 years, and in a lot of cases, less than 20 years. So it is an evolving field because the science is catching up with what we are seeing as known health effects. So hopefully in the next 10 to 20 years, this will continue to evolve to have very set, rigid standards and very obvious conditions. But in the meantime, we at least have ways that we can test and that we can view as good benchmarks for mitigation for areas that are known health risk. So particulate standards, the lead standards are for PM10 is less than 50 microns. For PM 2.5, it's less than 10 microns. Since PM10 also includes PM 2.5 particulates, Alpha uses the smaller standard for PM10 particulates as well. So basically, there are a number of different thresholds. Lead standards are specifically for building, new buildings that take place, and the standards that have been adopted by Oregon and some of the surrounding states. And that is for off-gassing and other types of particulate buildup. So what we've done is we've adopted the standard on the smallest, the most rigid standard, because again, these can affect people in different ways. We want to be as good at catching as many of those as possible.
We do have one question that came in. In testing air quality with respect to particulates, how can you determine if a home has high levels of mold spores or if it's just really dusty?
That's a great question. One of the things we do is if we have a question about whether mold is present in a house, we can start in one of two ways. We could start directly with an indoor air quality assessment, or we could move directly to a mold assessment. And in some cases, we actually would do both. Now, when we do a mold test, we actually will test for not only mold spores, but general particulates. So when we do our mold test, we actually test for about 20 different types of mold spores, and it will also test for particulates. So we actually get a good differentiation between whether the issue is mold-based or particulate-based. Indoor air quality doesn't differentiate between that, at least with the testing devices that we have. It tests only for particulates, which it would include mold. But if there's a very likely mold issue, then we would recommend doing mold air sampling, because that will differentiate between the dust or the specific mold spores. So hopefully that clears it up. And in some cases, it does make sense to do both an indoor air screening and a mold sampling. And actually, a lot of occupancy areas, commercial occupancy areas for working, we recommend doing both because of that, because mold is it's a different issue than particulates, obviously. And so having both sets of data can be very helpful. But when we're talking about residences, that is often a mold issue rather than a particulate issue. So in a lot of cases, it does make sense to move straight to mold sampling as part of that. So the particulate standards, getting back to that and finishing up this slide here, this is roughly equivalent to 100,000 mold spores, which is about 100, 200 times more spores than are typically found indoors. And going back to what we touched on briefly earlier, when we do mold screening, we generally do tests both outdoor and indoor, because if you test those at a similar time, generally back to back, one sample directly after another, you're going to have a good background of comparison. Weather is a huge impact on mold. Temperature is a huge impact on mold levels. So if you have an outdoor mold screening done first or done concurrently, then you have a general idea of what you can expect to see indoors. Generally indoors, you should see the same or lower. If you have levels that are higher, that is not uncommon. It's actually not uncommon to have levels as many as 5 times higher indoors than outdoors, because you can have that accumulation buildup. But if you have, say, 10 or more times more inside than outside, then you know that there's a mold issue. And that mold issue could be anywhere. So that does make mold a little bit tricky. And that's in large part when we do mold screening, we look at the whole area. We might look at the ducting. We might look at the attic and the crawl space. We might look at different areas where there's simply a lot of storage. And any of those could be a source for mold buildup and growth. Areas where there's not very much ventilation are generally the source of mold. So areas like crawl spaces or attics are more suspect because those areas might have limited ventilation. So having looked at the different parameters for which we've chosen to test, we can now get into indoor air testing. There's 2 types of testing. There's a short term, which is generally about 48 hours. This is the most common for what we recommend. And then we can do individual tests for specific parameters, such as individual VOCs, mold spore types, and types of particulates. So again, that's where we perhaps might recommend doing a mold spore test for air, because then we can actually get that information regarding different types of mold and different types of particulates. And again, this isn't necessarily a presentation on mold in particular, but it should be noted, since we're talking about it, that different types of mold aren't necessarily more toxic one to another. There are different types that might affect people in different ways, and so there might be different types of mold that might be considered more toxic for a specific person. But generally speaking, the molds that are most common are not necessarily incredibly toxic. It's something that we simply see in our environment. For Oregon and Washington especially, mold is simply a fact of life. It's just like radon. It is in all the air that we breathe. It is incredibly difficult to remove all the radon as it is to remove all the mold. Really, the only time you can remove those completely 100% is clean room conditions. So the indoor air quality testing, again, we can do the short term or we can do individual tests. We generally do recommend doing a short term 48-hour test. And those individual tests often take longer to complete, and they're generally more expensive. And in the case of mold spore sampling, those air samples are actually relatively affordable. VOCs are generally extremely expensive. They generally start at $700 to $900 at a minimum, and generally are more than that. And it should be noted that both tests determine the quality of contaminants, but may not determine the source. So looking again briefly, carbon dioxide levels in a building. Carbon dioxide really is a very good tracer for indoor air quality issues. A short-term test that was taken during the middle of a workday could indicate a high level of carbon dioxide level over 2,000 parts per million. However, the same test performed on the weekend would indicate a level that's 5 times less. So you can see these 2 peaks here. And we've talked about it briefly already, is when there's more people, there's more carbon dioxide. So this is why, in part, we do a 48-hour test, is because we see some of these conditions, and why in cases it is actually good to do the testing when the area is being used in a case of a work environment. So now, how do we improve indoor air quality? Indoor air quality is a combination of risk times exposure times concentration. So we really do look at all three of those things. When we look at risk, when we've done an indoor air quality screening, we will know the chemical toxicity, or at least a relative approximation of those different components. And exposure time, well, if we're doing a test in the basement and the people living in the basement have kids that might be down there 16 hours a day, then we know that that's a very long exposure time. And then in turns, we'll have the concentration of those contaminants. So we might know that if there's high levels or even moderate levels of these contaminants in an area that's being lived in or used a lot, then that increase the risk. So ultimately, that is what determines risk scientifically, is a combination of not only the levels, but how often the space is being used. So we can reduce the third term, the concentration, by reducing the indoor air concentration from the pollutant, ideally to zero. And there's three ways we can do this. Source removal, this is primarily for particulates. We have actually had success with VOCs as well, though. In some cases, we've done testing and we've had an indoor air quality screening moved around the house, and this has helped us to determine where the source was. So once the source was determined, then we can actually simply move that out of the house if it's, say, an accumulation of paints or other types of chemicals. Filtration is primarily for particulates. It's simply a large fan that would sit in the area, and then ventilation. So source removal is the most effective method, but it's not always the most practical. Obviously, if you have a pet that's contributing to the dust and dander buildup, you're not necessarily just going to remove your pet just because that's causing some of the issues. We generally recommend following accepted house cleaning practices. Dust hard surfaces. This prevents dust from becoming airborne. It's amazing how simple cleanliness and ventilation can improve air quality. We also recommend periodically vacuuming with a HEPA filter, and this removes a large amount of the particulates and actually will remove a lot of mold spores as well. Periodically cleaning HVAC air ducts is also a common one. Place welcome mats at entrances to remove shoes. As we noted, shoes, if being tracked around different areas, you're basically bringing those into the house from wherever you have been. So those can be simple things to remove some of the source. In some cases, sealing or encapsulating asbestos-containing material can be a good source removal, or simply removing the asbestos. Encapsulation actually is becoming less and less common in the asbestos industry, to a point where it is possible that it will not be considered a valid option. But removal of asbestos obviously would remove the source. Plants absorb some particulates and CO2, other gases. So actually putting more plants in the house can be a very healthy thing. They also generate more oxygen, which ultimately improves the air quality that we breathe. Minimizing the use of VOC emitting products as well. Those cleaners, again, moving those out into a storage area like a garage or a shed might be a better option. And making sure they're properly sealed and stored so they're not off-gassing more than they should. Also recommend adjusting gas stoves to cut down on emissions. Filtration, there are standalone filters to remove particulates. The bottom picture, it's maybe not as clear as it could be, but it's about a 3-foot high device, sitting fan that will actually pull in air and put out good clean air. And they do have to have filters replaced periodically, as noted. There are also devices that can be installed in the HVAC systems. We recommend contacting HVAC companies to see about that type of option. The stand-aside air fans are actually something that we provide as well. They're relatively simple to order and to install. The only downside there is the filters have to be replaced periodically. Ventilation, obviously this is one that also might not be as readily available in every case, but this removes the stale contaminated indoor air and replaces it with hopefully fresh outdoor air. And this is something that generally needs to be done by an HVAC company. So again, ventilation is especially applicable for activities that tend to produce fumes, particulates. And we might recommend using bathroom fans or oven fans to remove the excess humidity created by activities. This is especially common for mold buildup in attics and crawl spaces. It's simply lack of ventilation, so improving that ventilation can be helpful. We also recommend leaving the door open when the bathroom's not in use. We see a surprising amount of mold growth in bathrooms. Unfortunately, a lot of these are tenant-occupied situations in apartments where the bathrooms are likely in the middle of the building and simply they don't have enough ventilation. One fan going up into the attic might not be enough. So opening the door and keeping ventilation, which might include putting a fan in place, really do help preventing mold growth from occurring and overall the indoor air quality. So obviously this is still an evolving field, and there are other different things that can be done to improve the indoor air quality. Keeping conditions of temperatures and humidities are recommended. So humidifiers and dehumidifiers, and keeping your temperature gauge on the house consistent is also very helpful to moderate those conditions. So sick building syndrome, this is something that occurs when people suffer acute health effects inside a particular building. And often the symptoms will go away as soon as they leave the building. There's not necessarily a specific illness or cause, and the same remedies for indoor air quality apply to sick building syndrome. Some of the situations I mentioned earlier about people that had skin breakouts and terrible respiratory issues, we've actually done testing and determined that their house was the source of the problem. In some cases, we've been able to determine the source. In other cases, it's simply too hard to isolate. And in those cases, it's unfortunate, but in some rare cases, it might be that the person simply can't live there. And that shouldn't be viewed as necessarily an issue with the building, but it is worth noting that the person may simply have a compromised immune system. So we do have situations where people and even doctors will recommend that they move to an area with less air quality issues. We don't like thinking of Oregon as an air quality issue state, but it simply can have more mold than, say, Arizona or California. And ultimately, that might be something that might be best for them. If the issue is a high buildup of VOCs, then again, that's something that it might simply be related to the building itself. But it could be that there's low VOCs, low enough that we don't detect them with our testing equipment. And so, and again, rare cases, it might be that the person simply can't live there. So I wanted to briefly mention overall cost, because that ultimately is going to be something that will likely come into effect for you. So a typical 48-hour test for the Portland and Salem areas is $325 for us. That's a 48-hour test that tests for all those components. Testing for individual components such as VOCs, again, it's very expensive. We generally don't recommend it because of how expensive it is. Generally starts at $700 to $900 and often is more than that by the time we add up everything that needs to happen. Mold inspections and assessments, they generally start at $130 an hour, $130 total, for Salem and Portland areas, and that's primarily a visual search. If mold is suspected, we generally recommend doing a visual search first, because if there is mold, it's generally going to be pretty obvious. We don't actually see a lot of situations where mold's hiding behind walls and simply can't be gotten to. If mold sampling is needed, it's generally $85 per sample. Again, generally 2 samples are needed, so it would be 2 samples for that in addition to the inspection costs. In terms of treatment, as noted, contacting an HVAC company is recommended for a lot of the ventilation issues. The stand-aside fans are generally about $1,500, and the filters, they range in costs. Some of them are about $100 and some are more than that to replace. And unfortunately, those are things that have to run continuously, so it might be worth contacting an HVAC company to see if something more permanent can be installed. So I know we're pretty much at the end of our time here. If there are any other questions, please let us know. I did want to mention briefly some of the other environmental services we offer. We do offer radon testing mitigation, mold inspection and remediation, underground storage tank decommission and testing, sewer and septic, asbestos testing and removal, lead inspection, and for Portland area, home energy assessment. So we do offer a number of different areas of service, and this hopefully helps us in how we approach the environmental field to look at everything a little bit more practically And this also gives us a wide range of knowledge with things like mold when we're talking about indoor air quality, or things like radon. And so this generally can help us really quickly narrow down some of the issues. And just a brief close here, Alpha Environmental Services, no matter what the project type we undertake, the mission is the same: to address and mitigate the environmental issues and concerns. And we strive to do this as cost effectively as possible. So above all, we want your real estate transactions to be smooth and timely, and ultimately to get the issue solved. So that concludes our presentation.
All right, thank you, Zach. And like I said, we're gonna have Zach back May 17th to talk about the new rules for asbestos in Oregon. So look out for that webinar. Thanks, everyone.